Hello, everybody. How you guys doing? Welcome back to the channel. I hope you're having a wonderful day so far. Today is Wednesday, April 9th, 2025. And we're back. We're back. Doing some ProGit. We're going to be doing some ProGit today. How's it going, everybody? Welcome back in. I hope everybody's having a wonderful day so far. Let's get the chat loaded up here. Pop out, copy, come in here, paste. Yes, sir. All right, hello. Hello, AJ Brady. Hello, Mahan. Welcome back. Hello, Mr. Wing Hong. How you doing, guys? Welcome back into the usual suspects. I hope you guys are having a good day so far. Truly, welcome back in, you guys, and thank you guys for joining me every day. You guys are awesome. I like hanging out. I love hanging out with y'all. It's always a blast learning alongside you guys. Okay, so today's agenda. Today's exciting because I think we're going to wrap up a big chunk of the project, right? I think today on our CS50X final project, we are going to, we're working on that on the back half of the stream. And we are going to be going in and doing the balance sheet. So just to give you guys a little bit of a preview, we're going to get into Git Chapter 2, ProGit. Today we're going to be reading all of Chapter 2 and taking notes on it. So super excited to get into Chapter 2. Chapter 1 was super awesome too yesterday. So if you missed yesterday's Chapter 1, go back and reference that. We read Chapter 1. It took us about 55 minutes to read. So a quick short hour to get through Chapter 1. I think we can get through this book pretty quickly if we do about a chapter a day. I'm going to do about a chapter a day for the next, I know, about 10 or so days. And hopefully we can just bust through the chapter, pause, and get through the book pretty quickly. I don't see why there's any reason to. It's not as dense as like algorithms and data structures. It's just kind of learning just syntax and commands and what's going on. Kind of like as if we were learning a package or a library. So I feel like there's no reason why we can't just grind through it. Especially Git is super useful, and a lot of people will use it. So I think it's important for us to have these videos as references to go back on. So I want to do a chapter in a stream and really dedicate ourselves to committing to the reading here and going along. But yeah, so just a little bit of a preview. So on the Small Business Manager, or we have to think of maybe we'll choose a different name when we launch, maybe like Biz Wiz. Something like techie like that, like mid 2000s. Biz Wiz, I think would be cool. Or it's me. Yeah, I just got in from Walkener, actually. Yes, Mahan. So I was so today we're going to do the balance sheet, which is going to be pretty awesome. So I started to put together a framework on my lunch break today at work. I code on my lunch breaks and I code after work. I just code all the time. So must like it, huh? Let me know what you got. How long do you guys try to code every day, or what you guys' goal for coding, and or at least for learning? And do you guys have any goals for how what you guys like to do? And so on my lunch break, I threw together a little bit of a framework of how I wanted to structure the page. So I'll show you guys just quickly the balance sheet, right? I threw together also in our database a balance sheet, which is pretty simple. I kind of thought about it, and I also called my dad on my lunch break, who's the CPA, right? A certified public accountant. And I referenced, I said, my program isn't really set up to handle the entire business ledger in theory, right? It's not supposed to handle at this point in time, right? Right at this point in time, it's not supposed to handle. We can get into this later, but it's not supposed to handle like liabilities, like we talked about yesterday, or it's not supposed to handle, other types of, it's supposed to be pretty basic, but also pretty, advanced for at least our level, and at least for just a general business purpose. So in the ways that it's automatically creating income statements and stuff like that. So for the balance sheet, the only thing we have actually on our current the only thing that we have different on the current level is that we or the only thing we have currently data wise to report on the balance sheet is our only asset that we are collecting is the inventory, right? So what we have to report on the balance sheet for that calendar year is accumulation of the remaining inventory in the system at that point in time. And then once that calendar year closes, that balance sheet is sealed and we open a new one for the calendar year, and then we start generating, and then we populate from there the remaining inventory at that point in time. And we can keep going from then and on. So it's a summation, but we just have breakpoints at certain years to report for taxation purposes. So that is really the only asset that we're collecting here. We're not reporting cash or anything like that because that can be they're separate. Reporting. This is just to handle inventory and expenses, but what they can manage their own bank account however they would like. But so yeah, so it's going to be fairly simple in the fact that all we really need is to have a year and the unsold inventory summation, basically. Right, Wing Hong, they could use this. Well, yeah, exactly. Like in terms of like accounting, and we could report, so do like I can't talk today. Blah, 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 blah. We could report taxation statements, but in theory, it's pretty simple in terms of that. All they'll have to do is just take this income statement for these two points in time and provide that to their accountant, and their accountant will be able to just file for them with just this information. Their accountant won't need to go through and sort through all of their expenses and inventory on their own and generate their income statement themselves. In theory, they should just be able to take a snapshot at the end of the year of what this line is and hand that over, and then it's as simple as that. Like for my dad, for instance, who currently manages the taxes for my girlfriend's small business, is all she'll have to do is just at the end of the year take a screenshot or export this data, maybe with some functionality we write, export this data, and then just send that to him, and he will just say, okay, her income, and that income at the end of the year was positive or it was negative for these things. Now, of course, you'll have to bake in, of course, your cash and if you have any liabilities or things like that on there, but this is a huge chunk of what a small business is. Well, that's the thing, Mahan and Wing Hong. I think what we should do is after I submit this kind of more simple version, for a lack of better words, is that we can open it up and work on it as a group all together and really implement a lot more features. Right? We could make a section in the Discord where we plan out as a team, right? We plan out certain features we want and we assign certain tasks to people to build, and we really kind of make kind of like a mock team of for an open source project. Oh shoot. Didn't start Twitch. Thanks for the reminder, Tim. Twitch, my friends, we are back. Sorry, guys. I've been talking for the past 8 minutes about about the project and what we're going to get into later, but yeah. My parents' small business could use accounting software for taxes. Yeah, I was using taxes for small businesses is a huge time sink. Yeah, exactly. So this is like exactly what that goal was, right, Wing Hong? Is this is going to she can just take this number and give it to him because it's auto computing all of these all these returns and sales, and all of the expenses are being reported onto these income statements. And then right, your allowances go up for if you have returns, and right, and then they go down if you have sale, and then your gross sales go up if you have sales, right? Because your allowances offset those gross sales if you have returns. Hey, welcome in, Tim. So what do you guys think? I really think that would be like a good idea is once I submit this and get the credit for CS50, and then we open it up, um, and make it, a group project for the Discord, and we can, have a section in the Discord where we plan out features, and we can, if people want, they can, volunteer for certain things that they would like to build on, come after we've come up with some ideas and agree on what would be a nice thing to add, and we could just have it go from there. I think would be super cool. What do you guys think? Is that something you're interested in? I think it'd be fun. Well, that's the thing is we could really go anywhere from there, Edwards. I really don't know. It's gonna be done after we do the simple balance sheet, but from there, we could really expand it out into kind of anything. Hey, Round Dev on Twitch, thanks for coming in, man. Appreciate you joining me here. Welcome. We are just getting started here. We are going to, I'm just explaining our project that we've been building, our small business manager, and how we're about to wrap up and finish the balance sheet in the back half of the stream. But we're going to be getting into, guys, today is we're going to be jumping back into ProGit. Let's jump back into ProGit. Chapter 2. All right. Let's go. ProGit. Nice. That's chapter 1. Chapter 2. Chapter 2 nodes.md. Trevor, why do you use VS Code instead of PyCharm? I don't know. I think it's just because I started off with CS50 and that's what they had you use in the virtual environment. So I kind of just stuck with it. I have PyCharm though. I that's what I had downloaded at first because it was what people recommended. But then I did CS50 and you know. Connecting to a bank account would be a nightmare as different banks might have different data structures. No, you should talk with Mr. Big Deming and also get some connections to other accountants and research how you could do it. Yeah, I don't know if we'll we probably won't connect to bank accounts, but we'll probably just add more features as a group together. All right. Without further ado, let's get into chapter 2. 2.1, right, is going to be Git basics. Getting a Git repository. See if I can spell today. It's been a long day at work. I'm starting to get to that point at work where I've kind of been there long enough to where I'm starting to really kind of get involved in things, whether by my choice or not, and just for my, just because I have some tenure there. For those that don't know, I have a degree in human biology and a minor in chemistry, and I work as a formulation chemist for a biotech company every day as my 9-to-5 job, and I code every day and stream after work. But I'm at that point where I'm starting to just get called into more and more meetings, and I'm doing less and less chemistry. But that's what comes with it, I guess. All right, let's jump in here. Enough dilly-dallying. 2.1, Git basics. Getting a Git repository. If you can read only one chapter to get going with Git, this is it. This chapter covers every basic command you need to do, the vast majority of the things you'll eventually spend your time doing with Git. By the end of this chapter, you should be able to configure and initialize a repository, begin and stop track files, and stage and commit changes. We'll also show how to set up Git to ignore certain files and file patterns, how to undo mistakes quickly and easily, how to browse the history of your project and view changes between commits, and how to push and pull from remote repositories. You typically obtain a Git repository in one of two ways. Uh, you can take a local directory that is currently not under version control and turn it into a Git repository, or you can clone an existing Git repository. Okay, so there's we'll say 2 ways to typically get a Git repository. Number 1, you can turn a local directory that is not currently a Git repo and turn it into a Git repo. Okay. And then number 2 is clone an existing Git repo from elsewhere. Cool. In either case, you end up with a Git repository on your local machine ready for work. Initializing a repository in existing directory. If you have a project directory, okay. If you have a project directory that's currently not under version control and want to start controlling it with Git, you first need to go to the project's directory. If you've never done this, it looks a little different depending on which system you're running, right? So for Mac, you go cd into your project and type git init. Okay, so you say here, we'll go cd into cap locks. I gotta fix this key, it keeps getting stuck. I recommend you work with PyCharm for a little bit because you see some methods pop up while writing code and you'll learn some new stuff. Oh yeah, we should give it a shot next time around. Mike is gonna be the manager. Time to find a new job, Mahan says. I wish it was that easy, man. Market's brutal. They're gonna try to promote you before you enter the transfer portal. That's funny. My I don't know if this is, I don't know. I guess I could share. Like my manager just quit. Funny enough, so it's yeah. But there's someone that I think they're gonna ask to be it. Okay, so cd into the project directory, and then you what do? You git init. Type command git init. Okay, this creates a new subdirectory name called git. That contains all of your necessary repository files, a Git repository skeleton. At this point, nothing in your project is tracked yet. See Git internals for more information about exactly what files are contained in the Git directory you just created. If you want to start version control existing files as opposed to an empty directory, you should probably begin tracking those files and do an initial commit. You can accomplish this with a few git add commands that specify the files you want to track, followed by a git commit. We'll go over what these commands do in just a minute. At this point, you have a Git repository with tracked files and initial commit. Right, so in this line here, they git add all the files ending in .c. They add a file called license, and then they git commit initial project version with this as the message. We'll go over say cloning an existing repository. If you want to copy an existing repository, for example, a project you'd like to contribute to, the command you need is git clone. So git clone. If you're familiar with other VCSs, such as Subversion, you'll notice that the command is clone and not checkout. This is an important distinction. Instead of getting just a working copy, Git receives a full copy nearly all data that the server has. Every version of every file for the history of the project is pulled down by default when you run git clone. In fact, if your server disk gets corrupt, you can often use nearly any of the clones on any client to set the server back to the state it was in when it was cloned. You may lose some server-side hooks and such, but all the version data will be there. See getting git on a server for more details. You clone a repository with git clone URL, for example, if you want to clone a git linkable library like libgit2, you can do so like git clone https. Okay, I got you. So we'll say git clone URL. If you're probably part of the early crew, congrats, Mike, for what? No, dude, I'm definitely not going to be manager. There's no way. It's a whole different ball game. It's like money and it's no longer chemistry. Okay. Clone URL. This creates a directory named, let me bring this up so it's not blocked for you guys. Here we go. No, we're going to work on the project, Mahan. Tonight we're working on project. We got to keep project moving. We're almost done. That creates a directory named libgit2, initializes a .git directory inside it, pulls down all the data from that repository, and checks out a working copy of the latest version. If you go into the new libgit2 directory that was just created, you'll see the project files in there, ready to be worked on or used. If you want to clone the repository into a directory named something other than libgit2, you can specify the new directory name as an additional argument. The command does that same thing as the previous one, but the target directory is now mygit.libgit. Git has a number of different transfer protocols you can use. The previous example uses HTTPS protocol, but may also see Git or user at server path, which uses SSH transfer protocol. Getting a Git server will introduce all of the available options of the server, can set up access to your Git repository and the pros and cons of each. Okay, sweet. Moving on to 2. Git basics. Recording changes to the repository. All right. At this point, you should have a bona fide Git repository on your local machine and a checkout or working copy of all its files in front of you. Yes, I do. Typically, you want to start making changes and committing snapshots of all those changes into your repository each time your project reaches a state you want to record. Remember that each file in your working directory can be in one of 2 states, tracked or untracked. Tracked files are files that were in the last snapshot, as well as any newly staged files. They can be unmodified, modified, or staged. In short, tracked files are files that Git knows about. Okay, so hold on, we need to know this. Remember that each file in your working directory can be 2 states, tracked or untracked. So files in the working directory can be in 2 states. Number 1 is tracked, right? Tracked files are files that were written in the last snapshot. Files that were written. Oh no, tracked files are files that were in the last snapshot, as well as any newly staged files they can be unmodified, modified, or staged. In short, tracked files are files that Git knows about. Okay, and then 2, untracked. Untracked files are everything else. Any file in your working directory that were not in the last snapshot and are not in the staging area. When you first clone a repository, all your files will be tracked and unmodified because Git just checked them out and you haven't edited anything. As you edit files, Git sees them as modified because you changed them since your last commit. As you work, you selectively stage these modified files and then commit all of those stages, and the cycle repeats. So you add a file. Got you. Files that were not in the last snapshot and are not in the staging area. Checking files out, checking the status of your files. The main tool, okay, we'll say status files. The main tools geez. Mouse getting dry from talking so much. You guys like this hat? I know I think I got this one, I can't remember entirely. It might have been out of like I got a while back, like in 2020, 2019. I bought a hat mystery box, like a vintage hat mystery box. And I think maybe this was one of them. Or I found it at a thrift store. But yeah, Kentucky Derby. Yeah, we could probably do one at least, Mahan. I think we could do one. Leak code a day. Tim wants to buy the hat. I'll keep my eye out for some hats when I go out and see if you guys want them. Assassin's Creed game? Jeez, reach for the stars, Wing Kong. I like your thinking. Okay, let's keep on moving. Okay, the main tool you use to determine which files are in which state is the git status command. Git status. If you run this command directly after a clone, you should see something like this. On your master branch, your branch is up to date with origin/master, nothing to commit, working tree clean. This means you have a clean working directory. In other words, none of your tracked files are modified. Git also doesn't see any untracked files, or they would be listed here. Finally, the command tells you which branch you're on and informs you that it has not diverged from the same branch on the server. For now, that branch is always master, which is the default. You won't worry about it here. Git branching will go over branches and reference in detail. Note, GitHub changes the default branch name from master to main in mid-2020, and other Git hosts followed suit. So you may find that the default branch name is some newly created repositories is main and not master. In addition, the default branch name can be changed, as you have seen in your default branch name. So you may have seen a different name for the default branch. However, Git itself still uses master as the default, so we will use that throughout this book. Cool. So we'll say here, main or in GitHub versus master in Git. for default branch. Okay. Let's say you add a new file to your project, a simple README file. If the file doesn't exist before, you run git status, you see untracked files like so. Echo my project readme, git status on master branch, your files up to date with the origin master. Untracked files, use git add file to include what could be committed. Readme, nothing added to commit, but untracked files present, use git add to track. Woo. You can see that your new README file is untracked because it's under untracked files, heading in your status output. Untracked basically means that Git sees a file you didn't have in the previous snapshot commit and which hasn't been staged. Git won't start including it in your commit snapshots until you explicitly tell it to do so. It does this so you don't accidentally begin including generated binary files or other files that you did not mean to include. You do want to start including README, so let's start tracking the file. In order to begin tracking a file, use the git command git add. So, tracking a file, git add. To begin tracking the README file, you can run this, git add file name, right? So, we'll say git add file name. If you run your status command, again, you can see that your README file is now tracked and staged to be committed. New file README, staged. Changes could be committed. You can tell that it's staged because it's under the changes to be committed heading. If you commit at this point, the version of this file at this time you ran git add is what you will. If you commit at this point, the version of the file at the time you ran git add is what will be in the subsequent historical snapshot. You may recall that when you ran git init earlier, you then ran git add files. That was to begin tracking files in your directory. The git add command takes a path name for either a file or a directory. If it's a directory, the command adds all the files in the directory recursively. So git add directory. So in theory, it's just git add path, pretty much, right? Staging modified files. Let's change a file that was already tracked. If you changed a previous tracked file called contributing.md, then run your git status command again. You may see something that looks like this. New file readme, changes not staged for commit, use git add file to update what will be committed, contributing.md. The contributing.md file appears under the named changes not staged for commit, which means that the file that is tracked has been modified in the working directory but not yet staged. To stage it, you run git add command. Git add is a multi-purpose command. You use it to begin adding new tracked files to stage files and to do other things like make merged conflict files as resolved. It may be helpful to think of it more as add precisely this content to the next commit rather than add this file to the project. Let's run git add now to contributing.md to add. Let's run git add now to stage the contributing.md file and then run git status again. So let's go here into our own and say git status. As you can see, we have git will add the file to include that will be committed the directory chapter 2 and inward. So that's an untracked file. We haven't added it to the staging area. So we say git add chapter 2. No. So can we copy relative path and say git add chapter 2. Okay, so just wanted that without the thing. Now we say git status, and now we're having that this is staged to be committed. Let me say git, right, perfect. Perfect. Changes to be committed, right? Both files are now staged and will be in your next commit. At this point, suppose you remember one little change that you want to make to contributing before you commit it. Open it again and make that change, and you're ready to commit. Open it again and make that change, and you're ready to commit. However, let's run git status one more time. Okay, so the updated, okay, so it makes another layer. What the heck? The book literally wrote in what the heck. What the heck? Oh my gosh. Now contributing MD is listed in both the staged and unstaged. How is that possible? Well, it's possible because remember it talked about earlier that you can add, that just takes a snapshot of what it looked like, and then you made more changes. So those changes that you made post that snapshot add, so you need to re-add it again on top of it, right? And overwrite it. Is now listed in both the staged and unstaged. How is that possible? It turns out that git stages a file exactly as it is when you run the git add command. If you commit now, the version of contributing.md as it was when you last ran the git add command is how it will go into the commit, not the version of the file as it looks in your working directory when you run git commit. If you modify the file after you run git add, you have to run git add again to stage the latest version of the file. Short status. While the git status output is pretty comprehensive, it's also quite wordy. Git also has a short status flag. You can so you can see your changes in a more compact way. If you run git status -s or okay, so let's go here. So git status git status -s or git status short status. And we'll say note. Okay. You get a far more simplified output from the command. Git status okay, readme, got you. New files that aren't tracked have a question marks next to them. New files that have been added to staging have a next to them. Modified files have an M, and so on. There are two columns to the output. The left-hand column indicates the status of the staging area, and the right-hand column indicates the status of the working tree. So for the example example in the output, the README file is in the modified working area, right, via this on the right, but not yet staged. And the rake file was modified, staged, then modified again. So there are changes to it that are both staged and unstaged. Ignoring files. Often you have a class of files you don't want Git to automatically add or even show as being tracked. These are generally automatically generated files, such as log files or files produced by your build system. In such cases, you can create a file listing patterns. Create a file listing patterns to match them named git.getIgnore. Here's an example. Okay. All right, so ignore files. So we'll say .git ignore. The first line tells Git to ignore any files ending in an O or an A. object and archive files that may have been product of building your code. The second line tells Git to ignore all files whose names end in a tilde, which is used by many text editors such as Emacs to mark temporary files. You may also include a log, TMP, or PID directory, automatically generated documentation, and so on. Setting up a git ignore file for your new repository before you get going is generally a good idea so you don't accidentally commit files that you don't really want in your Git repository. The rules for the patterns you can put in the git ignore file are as follows. Blank lines or lines starting with hashtags are ignored. Okay, so we'll say specify patterns for files and file types to be ignored by Git. Then we say the rules for patterns, rules for patterns. Number 1, blank lines or lines starting with a hashtag are blank lines or lines starting with hashtag are ignored. 2, standard glob patterns work and will be applied recursively throughout the entire working tree. Not sure what that means. 3, you can start patterns with a / to avoid recursivity. 4, you can end patterns with a / to specify a directory. Number 4, you can negate a pattern by starting it with an exclamation point. So then we'll say, we'll go here and say this, glob patterns. Okay, glob patterns are like simplified regular expressions that shells use. An asterisk matches zeros or more characters. Lists, brackets, ABC matches any character inside the brackets, in this case A, B, or C. A question mark matches a single character, and brackets enclose characters separated by a hyphen. And brackets enclosing characters separated by a hyphen matches any character between them, in this case 0 through 9. You can also use 2 asterisks to match nested directories. Would match AZ, ABZ, ABCZ, so anything in between, and so on. Here's an example for git ignore. So git ignore all .a files. So you can use hashtags to specify a pattern. Oh no, so this is just a comment. So all A files are ignored. But do track lib.a even though you're ignoring it. Okay, so then you can ignore that. Okay. Only ignore the to-do file in the current directory, not subdir to-do. Okay, this is good. Let's go and take this. We need this for sure in our notes. tip, GitHub maintains a fairly comprehensive list of good git ignore files, examples for dozens of projects and languages, if you want a starting point for your project. Note, in the simple case, a repository might have a single git ignore file in its root directory, which applies recursively to the entire repository. However, it is also possible to have an additional git ignore files in subdirectories. The rules in these nested git ignore files apply only to files under the directory where they are located. The Linux kernel source repository has 206 git ignore files. It is beyond the scope of this book to get into details of multiple git ignore files. See man git ignore for the details. Okay, so you can nest, if you have multiple directories, git ignore files into other directories. Viewing your staged and unstaged changes. If the git status command is too vague for you, you want to know exactly what you changed, not which of the files were changed, you can use the git diff command. Okay, so we'll say view staged changes with the git diff command. We'll cover git diff in more detail later, but you'll probably use it most often to answer these two questions. What have you changed but not yet staged? And what have you staged that What have you changed but not yet staged, and what have you staged that you are about to commit? Although git status answers those questions generally by listing the file names, git diff shows you exactly the lines and lines added and removed, the patch as it were. Let's say you edit and stage the README file again, and then edit the contributing MD file without staging it. If you run git status command, you'll see something like this, where the stage to be committed is the README, and the changes staged, not staged, are the contributing. What you see, you've changed. To see what you've changed but not yet staged, type git diff with no other arguments. Shows you all of the changes then. So let's type in here git diff This is the line. Interesting. And if I command click this, it shows me the line. Oh, okay. And what about this one? Oh, these are the individual. Huh. Interesting. That command compares what is in your working directory with what is in your staging area. The result tells you the changes you made and haven't staged. If you want to see what you've staged that will go into your next commit, you can use git diff staged. So we'll say git diff -- staged. This command compares your staged changes to your last commit. Right, what this does compares what is in your working directory with what is in your staging area. If you want to see what you have staged, if you want to see what you so what this does is what I said below. There. So then here, stage, if you want to see what you've staged that will go into your next commit, see what you have staged that will commit. And the important note that it's important to note that git diff by itself does not show all changes made by your last commit, only changes that are unstaged. If all stages are, gosh, I cannot read today. If you staged all of your changes, git diff will give you no output. For another example, if you stage the contributing.md file and then edit it, you can use git diff to see the changes in the file that are staged and the changes that are unstaged. If our environment looks like this, you can use git diff to see what's still unstaged, and git diff cached to see what you staged so far. Okay. This is a long section. Git diff in an external tool. We will continue to use git diff commands in various ways throughout the rest of this book. There's another way to look at these diffs if you prefer a graphical or external diff viewing program instead. If you run git diff tool instead of git diff, you can view any of these diffs in software like emerging vim diff and many more, including commercial products. Run git diff tool --tool -help if to see what is available on your system. So here we'll say git diff tool will view diffs in file differences with external tools, not git standard diff. Okay. Committing your changes. Now that your staging area is set up the way you want, you can commit your changes. Remember that anything that is still unstaged, any files that you have created or modified that you haven't run git add on since that you edited them, won't go into this commit. They will say, dude, I cannot read today. Oh my gosh. Whoo! They will stay as modified files on your disk. In this case, let's say that the last time you ran git status, you saw that everything was staged. So you're ready to commit your changes. The simplest way to commit is to type git commit. Doing so launches your editor of choice. The editor displays the following text. This example is a Vim screen. Note, this is set by your shell's editor environment variable, usually Vim or Emacs, although you can configure it with whatever you want using the git config global core editor command as you saw in getting started. The editor displays the following text. This is an example from Vim screen. Please enter the commit message of your choice. Line starting with hashtags will be ignored and an empty message aborts the commit. On branch master, your branch is up to date with origin master. Changes to be committed, readme contributing.md. You can see that the default commit message contains the latest output of the git status command commented out on one empty line on the top. You can remove those comments and type your commit message or leave them there to help you remember what you're committing. Note, for an even more explicit reminder of what you've modified, you can use the -v option to git commit. Doing so also puts the diff to your change in the editor so you can see exactly what changes you're committing. So we'll say here git commit, right? Then you have git commit. Did it say anything else? Just the dash v. Right, this will just provides an explicit reminder of what you modified, right? And git commit, right? Just commits files, staged files, to the working branch, the main branch. Hey Ray, how's it going? Welcome in. How you doing? Okay. When you exit the editor, Git creates your commit with that commit message, with the comments and diff stripped out. Alternatively, you can type your commit message in line with the commit command by specifying it after a -m flag like this. So we know that one. Right? With quote a message. Right, can I italicize this? Yeah. Inside a code block? No. Or do I have to escape it? No. Doing good. We're just reading chapter 2 of ProGit right now. Getting some good notes going right here. What you working on? We'll bypass the text editor for providing a message to the commit and allow for an inline message to be provided at the time of call. Now that you've created your first commit, you can see that commit has given you some output about itself, which branch you've committed to, what SHA1 checksum that committed has, how many files were changed, and the statistics about lines added and removed in the commit. So let's do that here for us. So let's clear this out. How do I get out of this? Oh, that's it. Oh, you press enter to see them all. Okay. Okay, now let's go git status. Okay. Let's go git add chapter 2. Git status. There it is. Let's clear out. Let's go git commit -m started chapter 2. Okay, perfect. 2 files changed, 48 insertions. Create mode, there's my hash. Oh no, it didn't provide, there's my hash here. Or it might be this. All right, now you've created your first commit. You can see that the commit has given you some output about itself, which branch you've committed to, master, what SHA1 checksum the commit has, how many files were changed, and statistics about lines added and removed in the commit. Remember that the commit records the snapshot you set in your staging area. Anything you didn't stage is still there modified. You can do another commit to add it to your history. Every time you perform a commit, you're recording a snapshot of your project that you can retrieve it to compare it to later. Skipping the staging area. Although it can be amazingly useful for crafting commits exactly how you want them, the staging area is sometimes a bit more complex than you need in your workflow. If you want to skip the staging area, Git provides a simple shortcut. Adding the -a option to the git commit command makes the Git automatically stage every file that is already tracked before doing the commit. Okay, so you can just do every file that's already tracked. So here, git commit -a will make Git automatically stage every file that is already tracked before doing the commit, skipping the git add part. All right. Notice how you don't have to run git add on the contributing MD file in this case before you commit. That's because the -a flag includes all changed files. This is convenient, but be careful. Sometimes this flag will cause you to include unwanted changes. Removing files. To remove a file from Git, okay, so remove files. To remove a file from Git, you have to remove it from your tracked files. More accurately, remove it from your staging area, and then commit. Git rm command does that, and also removes the file from your working directory so you don't see it as an untracked file the next time around. If you simply remove the file from your working directory, it shows up under the changes not staged for commit. That is unstaged area in your git status output. Then, if you run git rm, it stages the files removal. So remove projects md git status, deleted projects md, no changes. Then, if you run git remove, it changes the files removal. Git remove projects md, remove projects md git status, deleted projects md. Oh, it's staged. To remove file, yeah. Tracked files. So tracked files are in the last snapshot and any newly staged files. The git rm command does that, and also removes the file from your working directory so you don't see it as an untracked file the next time around. If you simply remove the file, okay, the next time you commit the file will be gone and no longer tracked. If you modify the file or had already modified it to the staging area, you must force the removal with the -f option. This is a safety feature to prevent accidental removal of data that hasn't been recorded yet in a snapshot that can't be recovered from Git. If you modify the file or had already. Okay, so git rm, right, is to remove, but then git oh, so that just deletes it. So rm, so I'll just say rm file name dot extension removes the file from the working directory making the deletion a change that is not yet staged. Okay, but then if you git remove file name dot extension removes the file from the working directory, making the deletion a change that is staged to be committed. Then you can say git remove file name dot extension dash force, right, removes the file from force removes if said file is state added modified or added to the staging area. This is a safety feature to prevent accidental removal of data that hasn't yet been recorded in the snapshot, and that it can't be recovered from Git. Another useful thing you may want to do is to keep the file in your working tree, but remove it from your staging area. In other words, you may want to keep the file in your hard drive, but not have Git track it anymore. This is particularly useful if you forget to add something to your git ignore file and accidentally staged it, like a large log of a bunch of .a compiled files. To do this, use the cached option. So we got git rm -- cached on file name. Will remove the file from stop tracking on the file. Git will stop tracking the file, but the file will remain on disk. You can pass file directories and file glob patterns to the git remove command. This means you can do things such as this. You can pass files, directories, and file glob patterns to the git remove command. Note that the backslash in front of the star, this is necessary because Git does its own file name expansion in addition to your shell's file name expansion. This command removes all the files that have the .log extension in the log directory. Or you can do something like this, git remove /all tilde. This command removes all those file names with the end in a tilde. Moving files. Unlike many other CSVs, Git doesn't explicitly track file movement. If you rename a file in Git, no metadata is stored in Git that tells you rename the file. However, Git is pretty smart about figuring out that out after the fact. We'll deal with detecting file movement a bit later. Thus, it's a bit confusing that Git has a mv command. If you want to rename a file in Git, you can run something like git mv file from file2, and it works fine. In fact, if you run something like this and look at the status, you'll see that Git considers it a renamed file. So we'll say renaming files. This is going to be git mv file from file 2. This will change the name of the file from file file form. Okay. However, this is equivalent to running something like mv readme.md readme. Oh, so got you. Git figures out that it's a rename implicitly, so it doesn't matter if you rename your file in a way or that the mv command the only difference, or with the mv, the only real difference is that the git mv is one command instead of 3. It's a convenience function. More importantly, you can use any tool like a rename to rename a file, an address like add, remove later before you commit. Interesting. Hey, Go Guppy. Thanks for coming in on Twitch. How's it going, man? If I'm not mistaken, wouldn't it remove --cache keep the file tracked if it was already committed, but removes it from the staging area? Let's see. Another useful thing you may want to do is to keep the file in your working tree, but remove it from your staging area. So you keep the file in your working tree, but remove it from your staging area. In other words, you may want to keep a file on your hard drive, but not have Git track it anymore. Okay, so then it says, so let me just say, I think learning the Git fundamentals is imperative, but mastering it is imperative, but mastering it ... We're always, all the time, mastering it. LOL. Gotcha. Yeah, I'm trying to, let's ask the almighty orb here. Can you give a breakdown of git remove --cache file name? What it does, git remove removes the file from the git index, aka staging area, and usually deletes it from your working directory too. The cache tells Git to remove the file from the index only, not from your actual file system. Use case, you're tracking a file in Git, it's in your repo, but now you want Git to stop tracking it, for example. You accidentally add a file like env or config.py. You added that file that should be in a git ignore, but it's already being tracked. You can run the cached So I think my definition is right. Git will stop tracking the file, like if you wanted a Git to ignore the file completely, and then but it will remain within your working directory on disk. Within your working directory. So we'll say, so the file remains in the working directory. Gotcha. Past commits still contain the file. Okay, so we'll say past commits still contain the file. Hey, Vanch! How's it going? Welcome back, dude. It's awesome to hear from you again. What you been working on? Yeah. That's why we're trying to get a good understanding here. Try to understand this stuff. All right, let's move on here next. How many are there? Let me go here really quickly. Up to 2.8. Okay, geez. Might take us a little bit longer today. That's okay. It is what it is. Gotta learn it. 2.3, Git basics. Viewing the commit history. After you have created several commits or you have cloned a repository with the existing commit history, you'll probably want to look back to see what has happened. The most basic and powerful tool to do this is the git log. These examples use a very simple project called simple git to get a project run. Git clone, simple git, ProGit. Got you? So they clone this repo from GitHub. When you run git log in this project, you will get an output like this. Git log, commit, Arthur, got you, change version, commit, author, initial commit, got you. By default, with no arguments, git log lists the commits made in the repository in reverse chronological order. Okay, so we'll say git log say viewing, we'll just say here, viewing the commit history. We'll say here git log. List the commits made in that repository in reverse chronological order. That is the most recent commit shown up first. Perfect. Ooh. Caps lock sticky key again. Come on, get out of there. Get out of there. Here we go. Tushar, J.A.J. Brady says it undoes add. Tushar says, bro, the job market's F. I got 2 experience in dev ops, still no calls. Yeah, it's rough, man. Even in biotech too. If the file is tracked, it gets deleted. If it was not tracked, it gets unadded. I just tested it. When you get going to merging and rebind, you should 100% play along in your terminal. Yeah, we've been doing the commits here. All right, so let's git log here. Here's our commits here. Started chapter 2, chapter 1 complete. Okay, by default, okay. As you can see, this command lists each commit with the SHA1 checksum, the author's name and email, the date written, and the commit message. A huge number and variety of options to the git log command are available to show you exactly what you're looking for. Here, we'll show you some of the most popular. Some of the most helpful options is the .p or --hash, or sorry, --patch, which shows you the difference, the patch output introduced in each commit. You can also limit the number of log entries displayed, such as using -2 to show you the only last 2 entries. Okay, so they changed a version number in this commit, removed unnecessary test in this commit. Is the P, which shows the difference, the patch output introduced in each commit. Okay, so that we have git -p or git --patch. Right? Shows the difference, the patch output, right, introduced in each commit. Limit entries returned back with -2 hashtag. Where hashtag is a number. Is an integer. Okay. The option displays the same information, but with diff directly following each entry. This is very helpful for code review or to quickly browse what happened during the series of commits that a collaborator was added. You can also use a series of summarizing options with git log. For example, if you want to see some abbreviated stats for each commit, you can use the --stat option. So we can say git log --stat, which returns us what? Some abbreviated stats for each commit. You can use the stat option. Abbreviated stats. As you can see, the stat option prints below each commit entry a list of modified files. How many files were changed, and how many lines of those files were added and removed. It also posts a summary of the information at the end. So it prints below each commit entry a list of modified files, how many files were changed, how many lines of those files were added and removed. It also puts a summary of the information at the end. Another really useful option is --pretty. It's really giving it to us here. This option changes the log output to format other than the default. A few pre-built options values are available for you to use. The one-line value for this option prints each commit on a single line. Right, so this changes the log output to formats other than the default. And then we'll go here and say git log --pretty one line, pretty equals one line, not online, one line. This value, the one line value for this option prints each commit on a single line, which is useful if you're looking at a lot of commits. Then we have, let's take this up above. Let's just copy it down. And let's say, what's another one? We have short. We have full and fuller. In addition, the short, full, and fuller values are show the output in roughly the same format with less or more information. Okay. Git log, pretty one line. Gotcha. The most interesting option value is format, which allows you to specify your own log output format. This is especially useful when you're generating output for machine parsing because you specify the format explicitly, you know it won't change with updates to Git. Okay, so then you can do this git log pretty format, right? Which allows you to specify your own output format. Right. Oh, Vance message. Sorry. Currently working on a software engineering project with 4 other teammates. We're making a study group finder/creator kind of thing for a class, but I'm gonna put it on my resume. How about you? Nice, dude. That sounds fun. How is it working with like classmates in person on code? Like, it's probably, is it difficult, you find? Like, are people all at the same level, or how does that work? Pretty does not equal one line. This is especially useful in generating parsing UNO. Okay, so allows you to specify your own format log. And we'll go here, come down here, and give some bullet points here. Okay, I'm gonna come here. Take these. Copy image. Put this here. Okay, so it says useful specifiers for git log pretty format. List some of the most useful specifiers that format takes. So commit hash, abbreviated commit hash, tree hash, abbreviated tree hash, parent hashes, abbreviated parent hashes, author name, author email, author detail, author date, author date relative, author committer name, committer email, committer date relative, subject. You may be wondering what the difference is between author and committer. So say author versus committer. The author is a person who originally wrote the work, whereas the committer is a person who latest applied the work. Author, person who wrote the original, or who originally wrote the work. Then the committer, person who last applied the work. So if you send in a patch to a project and one of the core members applies the patch, both of you get credit. You as the author and the core member as the committer. We'll cover this distinction a bit more in distributed Git. The one line and format option values are particularly useful with another log option called --graph. This option adds a nice little ASCII graph showing you your branches and merge history. Okay, so you got this git log dash dash pretty equals dash dash graph. Option adds a merge history. Adds a ASCII graph showing your branch and merge history. This type of output will become more interesting as we go through branching and merging in the next chapter. There are only some simple output formatting options into the git log. There are many more. Those are only some simple. There are many more. Common options to git log list the options we've covered so far, as well as some other common formatting options that may be useful, along with how they change the output of the log command. We'll take that. So I'll paste this here. So this goes to pretty format though, so let's take this. We want to apply this under pretty format. And then we can apply this generally to everything. So I'll take this image actually, move this over here, put this on git log pretty. No, not git log pretty. We want to put it on git log. Like that. So now it's here. Perfect. Luckily, I know 3 of the teammates, so it's cool. The last guy is chill, but we're all learning as we go. I just have a bit more experience with like TypeScript, Tailwind, Git, so I just helped them when needed. It was supposed to be an easy project, but we got database involved, so all the backend stuff is annoying. I'm right there with you on the backend stuff with my project. It adds a whole nother level to things, for sure. Okay, let's keep chugging here. Okay, limiting log output. In addition to outputting format options, git log takes a number of useful limiting options, that is, options that let you show only subset of commits. You've seen only one such option already, the -2 option, which displays only the last 2 commits. In fact, you can do the dash some whatever bracket ends, where the n is an integer to show the last n commits. In reality, you're unlikely to use that often. Git by default pipes out all output through a pager, so you only see one page of log at a time. However, handling limiting options such as since or until are very useful. For example, this command gets lists of commits made in the last 2 weeks. Okay. So say limiting log output. Right, and say we can just say whatever. I think it's fine. So we'll take this then. Paste that there. Yeah, it's targeting that. Perfect. This command works with a lot of formats. You can specify dates like this or relative dates such as this. You can also filter the list to commits that match some search criteria. The author option allows you to filter specified authors, and the grep option allows you to search for keywords in the commit message. You can specify more than one instance of both the author and grep search criteria, which will limit the commit output to commits that match any of the author patterns and any of the grep patterns. However, adding the all match option further limits the options to just commit those match all grep patterns. Another really helpful filter is the -s option, colloquially referred to as the git's pickaxe option, which takes a string and shows only those commits that change the number of occurrences of that string. For instance, if you want to find the last commit that added or removed references to a specific function, you call git log s on function name. The last really useful option is to pass to git log, such as a filter is a path. If you specify a directory or file name, you can limit the log output to commits that introduced a change to those files. This is always the last option and generally preceded by the double hashes to separate the paths from the options. Okay. So you can do this -- path to file. Is a filter is a path. If you want to specify a directory or file name, you can limit the log output to commits that introduce the changes to those files. Oh, so you can put the log to that specific file. In options to limit the output of the git log, we'll see lists and a few other common options for your reference. For example, if you want to see which commits modified test files in the git source code history were committed by Junio Hermano in the month of October 2008 are not merge commits, you can run something like this. Log pretty with these indicators, author, right, since this date, before this date, no merges. Preventing the display of merging commits. Depending on the workflow used in your repository, it's possible that a sizable percent of the commits in your log history are just merged commits, which typically aren't very informative. To prevent the display of merged commits clustering up your log, simply add the log option no merges. All right. 2.4. Git basics. Undoing things. Undoing things. At any stage, you may want to undo something. Here we'll review a few basic tools for undoing changes that you've made. Be careful because you can't always undo some of these. You can't undo some of these undos. This is one of the few areas in Git where it may lose some work if you do it wrong. One of the most common undos takes place when you commit too early and possibly forget to add files or mess up your commit message. You may want to redo that commit, make the additional changes you forgot, stage them, and commit using the amend option. Okay, so undo things. Right, git commit -- amend. This command takes your staging area and uses it for the commit. If you've made no changes since your last commit, for instance, you run this command immediately after your previously commit, then your snapshot will look exactly the same, and all you'll change is your commit message. The commit message editor fires up, but it already contains the message from your previous commit. You can edit the message the same way, but it overwrites your previous commit. As an example, if you want if you commit and then realize you forgot to stage this changes in a file and want in a file you want to add to this commit, you can do something like this: git commit dash image commit, git add forgotten file, git commit dash amend. Okay. Um, so this takes your staging area. Commit message. It's important to understand when you're amending your last commit, you're not so much as fixing it as replacing it entirely with a new, improved commit that pushes the old commit out of the way and puts the new commit in its place. Effectively, it's as if the previous commit never happened. It won't show up in your repository history. The obvious value to amending commits is to make minor improvements to your last commit without cluttering your repository history with commit messages of the form "oops, forgot to add a file" or "darn, fixing a typo in the last commit." Only amend commits are still local and have not been pushed somewhere. Amending previously pushed commits and force pushing the branch will cause problems for your collaborators. For more on what happens when you do this and how to recover if you're on the receiving end, read The Perils of Rebasing. Unstaging a staged file. The next two sections demonstrate how to work with your staging area and working directory changes. The nice part is that the command you use to determine the stage of those two areas also reminds you how to undo changes to them. For example, let's say you've changed two files and want to commit them as two separate changes, but you accidentally type git add all and stage them both. How can you unstage one or of the two? Git status command reminds you that they're both there in the stages to be committed, or the changes to be committed. Right below the changes to be committed text, it says use git reset head file to unstage. So let's use that advice to unstage the contributing MD file. Git reset head contributing MD. Unstage is changed after reset. Perfect, here. The command is a bit strange, but it works. The contributing MD file is modified, but once again unstaged. It's true that git reset can be a dangerous command, especially if you provide the --hard flag. However, in the scenario described above, the file in your working directory is not touched, so it's relatively safe. For now, the magic invocation is all you need to know is that the git reset command will go into much more detail about what reset does and how to master it to do really interesting things in Reset Demystified. Unmodifying a modified file. If you want to realize what if you realize that you don't want to keep your changes to the contributing MD file? How can you easily unmodify it or revert it back to what it looked like when you last committed or initially cloned? However you got it in your working directory. Luckily, git status tells you how to do that too. In the last example output, the unstaged area looks like this: changes not staged for commit. Use git add file to update when committing. Use git checkout to discard changes in the working directory. It tells you pretty explicitly how to discard changes you've made. Let's do what it says: git checkout -- contributing.md. You can see that the changes have now been reverted. It's important to understand that git checkout file is a dangerous command. Any local changes you've made to that file are gone. Git just replace that file with the last staged or committed version. Don't ever use this command unless you absolutely know what you've done. Know that you don't want those unsaved local changes. If you would like to keep the changes you made to that file but still need to get it out of the way for now, we'll go over stashing and branching in git branching. These are generally better ways to go. Remember anything that is committed in git can almost always be recovered. Even commits that were on branches that were deleted or commits that were overwritten with an amend commit can be recovered. See data recovery for data recovery. However, anything you lose that was never committed is likely never to be seen again. undoing things with git restore. Git version 2.23 introduced a new command, git restore. It's basically an alternative to git reset, which we just covered from Git version 2.23 onwards. Git will use git restore instead of git reset for many undo operations. Let's retrace our steps and undo things with git restore instead of git reset. Unstaging a file with git restore. The next two sections demonstrate how to work with your staging area and working directory changes with git restore. The nice part is that the command you use to determine the stage of those two areas will also remind you how to undo changes to them. For example, let's say you've changed two files and want to commit them as two separate changes, but you accidentally type git add all and stage them both. How can you unstage one of them? The git status command reminds you that both of them are in these changes to be committed. Right? Right now, the changes to be committed text is also says git restore staged file to unstage. So let's use this advice to unstage the contributing MD file. What did it say before? Git reset on status. Git restore. Unstaged. Unmodifying and modify file with git restore. What if you realize that you don't want to keep your changes to the contributing MD file? How can you easily unmodify it, revert it back to what it looked like when you last committed or initially cloned, or however you got into working? Luckily, git status tells you what to do with that too. In the last example, output the unstaged area looks like this. It tells you pretty quick. So like git restore and git reset are the same thing. We'll use git restore instead of reset for many undo operations. Okay. Interesting. I'll have to come back and get some more notes on those. I'm getting a little bit tired here. Basics with notes. I don't know if we'll be able to work on the project today. This chapter is taking a little bit longer. This one's not too long. Working with remotes. To be able to collaborate on any Git project, you need to know how to manage your remote repository. Remote repositories are versions of your project that are hosted on the internet or network somewhere. On the internet or network somewhere. You can have several of them, each of which generally is either read-only or read-write for you. Collaborating with others involves managing these remote repositories and pushing and pulling data to and from them when you need to share work. Managing remote repositories includes knowing how to add remote repositories, remove remotes that are no longer valid, managing various remote branches and define them as being tracked or not, and more. In this section, we'll cover some of the remote management skills. Note, it is entirely possible that you can be working with a remote repository that is in fact on the same host you are. The word remote does not necessarily imply that the repository is somewhere else on the internet or network, only that it is elsewhere. Working with such a remote repository would still involve all the standard pushing, pulling, and fetching operations as with any other remote. Showing your remotes. To see which remote servers you have configured, you can run the git remote command. It lists the short names of each remote handle you specified. If you've cloned your repository, you should at least see origin. That is the default name Git gives to the server you clone from. So you clone a repository, you call remote on it, and you see origin. You can also specify. Okay, so I'll just say here. Right, git remote um, shows which remote servers are configured to said repo. You can also specify -v to show you the URLs that get us stored for the short name to be used when reading and writing to that remote. Shows the URLs reading and writing to that remote. If you have more than one remote, the command lists them all. For example, a repository with multiple remotes from working with several collaborators might look like something like this. This means we can pull contributions from any of these users pretty easily. We may additionally have permissions to push one or more of these, though we can't tell that here. Notice that these remotes use a variety of protocols. We'll cover more about this in getting Git on a server. Adding remote repositories. We've mentioned and given some demonstrations on how the git clone command implicitly adds the origin remote for you. Here's how to add new remote explicitly. To add a new remote git repository as a short name, you can reference easily run git remote add short name URL. Git remote origin, git remote add pb htms this. Note that you can use the string pb on the command line instead of the whole URL. For example, if you want to fetch the information that Paul has, but you don't yet have it that Paul has, but that you don't have yet in your repository, you can run git fetch pb. And that'll fetch all of the that Paul has. Interesting. So you go git remote add short name and URL. And then so Paul's master branch is now accessible locally as pb/master. You can merge it into one of your branches, or you can check out a local branch at that point if you want to inspect it. We'll go over what branches are and how to use them in much more detail in Git branching. Fetching and pulling from your remotes. As you just saw, to get data from your remote projects, you can run git fetch remote. Fetching and pulling data. As you can saw, to get data from your remote projects, you can run git fetch remote. So this will get data from your remote projects. The command goes out to that remote project and pulls down all the data from that remote project that you don't have. After you do this, you should have references to all of the branches from that remote which you can merge in or inspect at any time. If you clone a repository, the command automatically adds the remote repository under the name origin, so git fetch origin fetches any new work that has been pushed to that server since you cloned or last fetched from. It's important to note that the git fetch command only downloads the data to your local repository. It doesn't automatically merge it with any of your work or modify what you're currently working on. you have to merge it manually into your work when you're ready. In your current branch, if your current branch is set up to track remote branches, see the next section and Git branching for more information. You can use the git pull command to automatically fetch and then merge that remote branch into your current branch. This may be easier or more comfortable workflow for you, and by default, the git clone command automatically sets up your local master branch to track the remote master branch, or whatever the default branch is called on that server you cloned from. Running git pull generally fetches data from the server you originally cloned from and automatically tries to merge it into the code you're currently working on. From Git version 2.27 onward, git pull will give a warning if the pull rebase variable is not set. Git will keep warning you until you set the variable. If you want the default behavior of Git, fast forward if possible, else create a merge commit. Whatever, I'm not sure what that means. Pushing to your remotes. When you have your project at a point that you want to share, you have to push it upstream. The command for this is simple: git push remote branch. See, this is where I'm starting to fade. How much longer do we have? Tagging, it's pretty long. That's short, and then it's summary. We can do it. We can push through. It's already 9 o'clock. Jeez. Should I break it up into 2 parts? Or keep going? What do you guys think? Git fetch remote. So we'll say git pull automatically fetch and then merge, right? And then pushing git push remote branch. When you have a project at a point you want to share, you have to push it upstream. The command for this is git push remote branch. If you want to push your master branch to your origin server, again, cloning generally sets up both of these names for you automatically. Then you can just run this push any commits you've done back up to the server, git push origin master. This command works only if you've cloned from a server to which you have write access, and if nobody has pushed in the meantime. If you and someone else clone at the same time and they push upstream and then you push upstream, your push will rightly be rejected. You'll have to fetch their work first and incorporate it into yours before you'll be allowed to push. Oh, interesting. Inspecting a remote. If you want to see more information about a particular remote, you can see the git remote show command. If you run this command with a particular short name such as origin, you'll get something like this. More information on you there. Right. It lists the URL for the remote repository as well as the tracking branch information. The command helpfully tells you that if you're on the master branch and you run git pull, it automatically merges the remote's master branch into the local one after it has been fetched. It also lists all the remote references it has pulled down. That is a simple example you're likely to encounter. When you're using Git more heavily, however, you may see much more information from Git remote show. this command shows which branch is automatically pushed to when you run git push while on certain branches. It also shows you which remote branches on the server you don't yet have, which remote branches git remote show origin. Gotcha. Renaming and removing remotes. You can run git remote rename to change the remote short name. For instance, if you want to rename PB to Paul, you can do so with git remote rename Paul. Okay, let's add another command here. Hey Sergio, thanks you for the hype. We can get through it today, I believe. Thank you guys for the keeping me going here. You can run to change your remote short name. It's worth mentioning that this changes all your remote tracking branches names too. What used to be referenced as pb-master is now paul-master. If you want to remove a remote for some reason, you've removed the server or no longer using a particular mirror, or perhaps a contributor isn't contributing anymore, you can either use git remote remove or git remote rm. Git remove or git remote rm. This will, if you want to remove a remote, right? If you guys are still with me here, feel free, please, if you could, leave a like. Appreciate you guys for being here. Oh, we lost a sub live. Dang, brutal. Oh, tough luck. You roll the dice by showing the sub count live. You can go up or down. Once you delete the reference to a remote this way, all remote tracking branches and configuration settings associated with that remote are also deleted. Okay, 2.6. Git basics tagging. Like most virtual control systems, Git has the ability to tag specific points in a repository's history as being important. Typically, people use the functionality to mark release points v1, v2. In this section, you'll learn how to list existing tags, how to create and delete tags, and what different tag types are. Listing your tags. Listing the existing tags in the Git is straightforward. Just type git tag with the optional L or list. This command lists the tags in alphabetic order. The order in which they are displayed has no real importance. You can also search for tags that are matched for a particular pattern. The Git source repo, for instance, contains more than 500 tags. If you're interested in only looking at the 1.8.5 series, you can run this. Okay, so you have tags are specific points of being important, right? So then here we have a git tag. You can say git tag -L or git tag --list, right? So this lists all the tags in alphabetical order. Creating tags. Git supports two types of tags, lightweight and annotated. Two types of tags. Number one, lightweight. And number two, annotated. Right? A lightweight tag is very much like a branch that does not change. It's just a pointer to a specific commit. A pointer to a specific commit. Annotated tags, however, are stored as full objects in the Git database. They're checksummed, contain the tagger's name, email, and date, have a tagging message, and can be signed and verified with a GNU privacy guard. It's generally recommended that you create annotated tags so you can have all of this information. But if you want a temporary tag for some reason, don't want to keep the other information, lightweight tags are available too. Right here. It's annotated. Creating an annotated tag in Git is simple. The simplest, easiest way. Let me take this. We'll just move this down. The easiest way is to specify a -a when you run tag command. The -m specifies a tagging message, which is stored with the tag. If you don't specify a message with the annotated tag, Git launches your editor so you can type it in. So this is git tag -a tag title -m quote message. Creates a tag you can see the tag data along with the commit that was tagged using the git show command. So git show given some tag title output shows the tag information data. Lightweight tags. Another way to tag commits is with the lightweight tag. This is basically the commit checksum stored in a file. The commit checksum stored in a file. No other information is kept. To create a lightweight tag, don't use any of the -a, -s, or -m positions. Option just provide a tag name. So this is going to be an annotated tag. Right. You say show tag title. And then a lightweight tag is going to be creates an annotated tag. This one. Right, git tag title. Creates a lightweight tag. This time, if you run git show on the tag, you don't see the extra tag information. The command just shows the commit. Tagging later. You can also tag commits after you move past them. Suppose your commit history looks like this. Now, suppose you forgot to add a tag at project v12 1.2 where it shows the update rake file commit. You can add it after the fact. To tag, you can specify the commit checksum or part of it at the end of the command. So let's take this here. Put this here. Get add tag. Creates a tag on a past commit via its hash, its checksum code. Tag, so this will be tag title, and this will be checksum code. Shearing tags. By default, the git push command doesn't transfer tags to remote servers. You have to explicitly push tags to a shared server after you created them. This process is just like sharing remote branches. You can run git push origin tag name. So here, they use tag name instead of tag title. Hey Alex, my team only knows git push and git pull. Hopefully we're trying to level up our game here. Thanks for joining me, Alex. How's it going, man? Git push origin tag name. Tags. We'll say pushing tags. Tags. We'll say here tags pushes the tag with tag name to the origin branch. Then you have this one though, git push origin tags, right, which will push all tags to the remote server. Not bad. Waiting for layoffs at Amazon. Oh, are you on the receiving or the hoping to get a job from the layoffs? Like swoop in and swipe one up. Oh, maybe we didn't go down. We went up on subs. I think we were at 44 before. I think we went up. We just went up another one. Hey, we just went up a sub. If that was you, I saw you. Thanks for coming in and subbing. Make yourself known in chat. Number 1646. Appreciate you for that sub. I saw that climb up. That was cool. Haha. Okay. If you have a lot of tags you want to push all at once, you can use the tags option to the git push command. This will transfer all of your tags to remote server if they're already there. Now, when someone else clones or pulls from your repository, they get all your tags as well. Git push pushes both types of tags. Git put remote -tags will push both lightweight and annotated tags. There is currently no option to push only lightweight tags, but if you use git push follow tags, only annotated tags will be pushed to the remote. Only annotated tags will be pushed. Deleting tags. To delete a tag, right? To delete a tag on your local repository, you can use the command git tag delete tag name. For example, we could remove the lightweight tag above as follows. This deletes a tag. Delete okay. Note that it does not remove the tag from any remote servers. There are two common variations for deleting a tag in the remote server. The first variation is git push remote refs tags tag name. The way to interpret the above is to read it as the null value before the colon is being pushed to the remote tag name, effectively deleting it. Oh, this value here before the colon. The second and more intuitive way to delete a remote tag is with this. Delete. So we'll say deleting remote tags. Deleting tags. Deleting remote tags. We'll say deleting local tags. This. Or this one. Checking out tags. If you want to view the versions of files a tag is pointing to, you can do it with the git checkout of that tag. Although this puts the repository in detached head state, which has some ill side effects. If you want to view the versions of file as git checkout of that tag. So this is checking out tags. Git checkout, right? View the versions of okay, so view the versions tag, the tag name. Yeah. We'll say puts the repository in a detached head state. In detached head state, if you make changes and then create a commit, the tags will stay the same. In detached head state, if you make changes and then create a commit, the tags will stay the same, but your new commit won't belong to any branch and will be unreachable except in the exact commit hash, except by the exact commit hash. Thus, if you need to make changes, say you're fixing a bug on an older version, for instance, you will generally want to create a branch. If you do this and make a commit, your version 2 branch will be slightly different to your v2000 tag, since it will move forward with your new changes, so do so carefully. Explain detached head state. A detached head state in Git happens when you're no longer on a branch, but instead a checked out specific commit. Okay. Cool. 2.7, last section here. We got it, guys. We're almost there. You guys are awesome. Let me know if you've been here this time and you're reading along here with me. I know it's not the most exciting stuff in the world, guys, but this is a standard software, you know, implemented across many different, you know, globally programs and industries. So we got to know it. Git aliases. Before we move on to our next chapter, we want to introduce a feature that can make your Git experience simpler, easier, and more familiar. Aliases. For clarity's sake, we won't be using them anywhere else in this book, but if you go on to use Git with any regularity, aliases are something you should know about. Git doesn't automatically infer your command if you type it in partially. If you don't want to type the entire text of each Git commands, you can easily set up aliases for each command using git config. Here are a couple of examples you may want to set up. Okay, so what are Git aliases? So we'll say shortcuts customized by the user to shorten calls to Git commands. We'll say aliases can be defined within the git config command. Git config alias checkout as co br ci st as status. This means that, for example, instead of typing git commit, all you need to do is type git ci. If you go on using Git, you'll probably use other commands frequently as well. Don't hesitate to create new aliases. I'm going to take this here. Stock price dropped a lot at Amazon because you know what? People are freaking out. Yeah. Your boy was really happy, actually. Well, sorry, dude. This might be bad taste. I don't know, but I was happy Amazon's price took a dip because I went and started buying. Let me tell you, Amazon at 150, buy that up. Like Amazon 160, buy it up. Like it's like normal price is like 190 on a typical, like how it likes to kind of balance and average out at. So like that's already what, 15%, something like that. So, and just off of a like a fair market value discount, like it just seems like free money. Like as long as you're just willing to wait a little bit, it's free money. We'll see. But if people are freaking out at Amazon, then maybe that's not a good sign. If the employees are freaking out. Uh-oh. It's all right. We didn't go in heavy, though. We're averaging in over time. We got a lot of time on our hands, being 26 years old. For those that are new here, my name is Michael. I've been teaching myself how to code for about 10 months now. We've read various books such as Python Crash Course. We're currently reading data structures and algorithms in Python, Fluent Python, and now ProGit. We're going to move through the ProGit pretty quickly, doing a chapter a day. So hopefully by the end of like a week or 10 days, we'll be through the book entirely. But we're going to continue on with Fluent Python and DSA and Python here and there. We also do leak code problems and we do projects. I've made a couple of various projects. We've done CS50 courses. I've been really dedicated to teaching myself over these past 10 months. I have a degree in human biology and a minor in chemistry, and I work as a formulation chemist for a biotech company where I make biological controls for patient diagnostics and research purposes, or really whatever, whoever wants to buy them. And I've been doing that ever since I graduated college, but I've been really interested in learning and teaching myself computer science and programming. For example, here, like I have a small business manager project that I've been building here, and I'll show you guys. I built this entirely from scratch into Kinter, multiple tab windows, database, pull it, fetch requests, populating matrices with stuff from our database, auto transacting income statements based on user transactions of the inventory items and expenses are being populated for those calendar years appropriately. The transactions allow for returns of items to be populated into allowances for that calendar year. So it's really, really cool. I mean, we've learned a ton so far, and we're only learning more. So if you're here, leave a thumbs up if you're new, and consider subbing along. Hey, we got someone, 1247. If that was you, thank you so much. Appreciate you. Make yourself known in chat. I'd love to meet you, Mr. 1647, whoever that was. Appreciate you guys joining me. Yeah, we wrote that. We've been writing that we've been writing the whole project for the initial version since like December, but that current version we've only been writing it for less than a month. That GUI version. So we've been really speeding up here. But let's get through this. We're almost done with this chapter. This technique can also be useful in creating commands that you think should exist. For example, to create the usability problem you encountered with unstaging a file, you can add your own unstage alias to Git. Git config -global alias.unstage reset head --. This makes the following two commands equivalent: git unstage file A, git reset head -- file A. Oh, so you can set alias unstage as this quote. Okay, it seems a bit clear. It's also common to add a last command like this: git config global alias.last log -1 head. This way you can see the last commit easily. Git last. Oh, you're setting an alias to that commit. Okay. So we'll say useful for creating commands. You think should exist, right? And then I'll give this example here. Oop, my bad. This copy image like that, and then we'll copy this one here. Right. As you can tell, git simply replaces the new command with whatever you aliased it for. However, you may want to run an external command rather than git subcommand. In that case, you start the command with a exclamation point character. This is useful if you want to write your own tools that work with the Git repository. We can demonstrate it by aliasing git visual to run git k. An external command. Huh. external commands I don't really know what that means. Anybody know what external commands? Hey, Loomer. How's it going? Yeah, Andrew, it's probably is temporary. There's a lot of, up and down in the market. Dude, honestly, my biggest thing I've been noticing is it's been really prevalent, obviously the past couple of years, but it's even more so now on all sides of the fence, no matter who it is the amount of fake news. Like, I know it's such a trigger word, but it's really, I honestly, I haven't experienced as much fake information as there has been these past like 6 months. It seems like every news outlet is just trying to it's just clickbait, dude. It's just turning into YouTube thumbnails everywhere, and everybody's just one upping each other with some lie, honestly, to try to entice viewers, and it's really I don't know, man. Like I don't know where to look for actually accurate information. I'm not even sure if I really trust like reportable or accredited like fed data anymore. Like it's just so it just seems very skewed to lobbyists or just it's just really strange. You guys notice that a lot more? It's just the information is so scattered everywhere. You can't get like a unbiased viewpoint anywhere. All right. And 2.8. Git basics summary, right? At this point, all you can do all the basic local Git operations, creating or cloning a operation repository, um, making changes, stating changes committed, viewing the history changes, and has been through. Right, learned, creating or cloning repository, learned about creating or cloning a repository, making changes, staging, committing those changes, and viewing the history of all the changes. Hey, we're at 1648. Thanks you guys so much for being here. All right, we just finished chapter 2 of ProGit. Woo, 2 days, 2 chapters. Awesome. That's nice. Let's see. Chapter 3 is going to be tomorrow, so make sure you guys join back for chapter 3. Looks like it's a little bit shorter than chapter 2, so hopefully it goes well. Git branching might be a little bit more confusing, so we haven't actually gotten any experience doing that before, so we'll really have to get some practice with that. The basics we've done some before, obviously, but branching is a whole new ballpark. So we're going to get into chapter 3 tomorrow, so make sure to join back for then. This stream did take a little bit longer than normal. The Git basics section was fairly long. Section 2. Was it 2? Yeah, 2.2 is pretty lengthy here. So I really apologize that we weren't actually able to get to the small business manager today. I was really actually excited to work on it because I wanted to finish the balance sheet. So as you guys know, this is the small business manager project that we've been writing on for the entire, for about, this current version about a little less than a month, about a couple weeks, about 3 or 4 weeks, and then the entire version since about December. It's nothing crazy, but so our current version is pretty cool in that we have a whole working Tkinter GUI we've made from scratch and designed. We have the ability to search or add inventory items, add expense items, transact and return, sell and return items in inventory, and then automatically populate income statements based on that information. This all happens automatically on the back end. So now our next task is to actually populate a balance sheet, which is going to be fairly easy, I think, because after speaking with my accountant, who gave me some advice on this, who happened to also be my dad, he's a retired CPA, he told me that this business, the model right now is really only having one typical type of reportable data on the balance sheet that you're taking in, right? And so on this kind of partial balance sheet. It's not a full balance sheet you'd want to report to your accountant. Obviously, there's things like cash and liabilities and owner's equity and things like that you need to take into account. But for just a partial balance sheet reporting and taking tracking inventory and stuff like that and sales is the only thing that's reported at the end of the calendar years or periods, whatever you're tracking, is the remaining assets and inventory, right? That inventory that you bought, that you traded cash for when you acquired it from the manufacturer or from wherever you sourced it, is an asset. It's not an expense, because you can obviously take that inventory has worth. Now, if it continually depreciates, then you have certain depreciation things you add in on the income statement to show, I have depreciation for those assets, but we don't have any depreciation here, or baked into this program. We are just, it's simple. It's not simple, but it's a simpler way of, accounting purposes. So, right, we're going to need to figure out a way to auto compute at the end of periods a finalized remaining inventory amount, right? So of cost. So each inventory item has a cost associated with it, right? So let's say at the end of this calendar year, 2025 ended, our balance sheet would show $0 for remaining inventory, right? Because all of our items in inventory are sold under this calendar year for 2025. They're all in sold status. So what we need to do is, we need to fix a bug, is that we are currently allowing the users to create sales in the future, right? So something that will be easy to actually implement and not allow this to happen and scale this is that we have in our auxiliary functions a check date function, which we are returning the checked date if applicable, or an error if it's invalid. Now, what we can do is, before we return this date, we can determine if this date is in the future of our current date object. So we are currently using date time. So what we'll do is what we can do is really quickly, actually, so let's go ahead and just do something here, is we can say current, so let's actually go like this, current date is equal to date time dot date time dot date dot today. I think it's that. Or is it date time dot date dot today? Yeah, like that. So we have this function. So I'm not sure though. Let's ask, can we or date time objects? Yes, you can use operators to compare date time objects in Python. Okay, so if check date so what I'll do is I'll take this out of the value here. So we'll say try if check date is greater than current date, right? Oh, so we don't even need to do that. We don't even need to do a try. We'll just do this. If check date, we're going to raise a value error with invalid date future date format. Invalid date format. We'll specify the format as year, year, year. Validate format. Year, month, day. Like so. Invalid future date. Invalid date. Future date. Okay. So if the check date is greater than the current date, then we're going to raise this value, or else we're going to just return, right, stir of checked date back to it. So now, if I quit this and I run my program, and I try to add in an item that's in the future, 2025-04-10, description, test, size, medium, cost, 10, add, boom. Invalidate future date. Woo! See, so simple. Because we added these auxiliary functions to do these checks, it's really easy to actually add in additional checks, and it's universally being applied to all of our date calls across these inputs, right? And so we don't have to go into each tab and change that, because we're universally applying that date check to these. And so because the whole point of this is we don't want the user to be able to input a date into the future, because if they do so, then that will automatically negate or, finalize or cancel our current balance sheet. And plus, they shouldn't be allowed to even enter a date into the future. So, right, you can't make future sales. Yeah, you can pre-sell stuff, but it really doesn't make sense for this kind of business model. So what we're doing is not allowing for sales to be made within the future. So that way, what we can do is in the balance sheet is then we can identify, right, at that point in time, once that time closes. So let me go here to that balance, to the inventory tab. We have a label here for a status label here, right? And we need to wrap text, wrap length to like 50 here. And then let's close this. Let's go run here. 2025-04-10, test, size, medium, 10, add, invalid future date. So we'll increase that from 50 to, let's say, 100. Clear. Inventory 2025-04-10, test, medium, cost 10, add, invalid future date. Let's wrap 150. This entire frame is what? The frame is size 350 minus 65. So, okay, it should be enough. So 2025-04-10, test, invalid date, future date. So let's wrap 200. future date. Perfect. That looks good. And then let's go. We want to do a line, or what is it called? Justify center. So now that'll make it so it's centered. 2025 0 and then 10 test as medium 10. There we go, perfect. That looks really good. Okay, so now you can't put items into the future, right? And you shouldn't be able to sell stuff in the future. So that being said, we want to get the current calendar year. Balance sheet years. Okay, I'm gonna have to think about this. So what we're gonna have to do is get the current calendar year live, reference our past calendar years saved, right? And then we would have to Oh, Wing Hong, sorry, I missed your thing. I agree on fake news. That's why I hate when people think Linus was RMS, my friends who made the entire OS. Oh, interesting. Very interesting. Okay, so how do we want to do this? So for the balance sheet, right, the thing is we need to take basically screenshots. So you can't put stuff in this, but you can do it in the past. So basically, so you also, so let's do this. Let's check date. Auxiliary function. In our check date function, let's extract the year. Right? So you can't make transactions for the previous year either. So well, do I want to allow that? Is it bad to allow transactions for the previous year? Oh yeah, because you would have to go back and edit the cost of the assets remaining for that year. So if we just make it so that you can't sell items from into the previous year. So let's just go like this. If current, or if okay, so if checked of 4 if int check date slice of 4 is less than int current date slice of 4, right? We're going to raise value error and say invalid date previous year right? So now if we run appy and go item for 2024-04-09 test cost 10, that's expense. Let's go add it. Item 2024-04-09 set whatever. Test size medium cost 10 add. Got this error. Date time object is not scriptable. Okay, so we first need to, what we first have to do is go like this. Stir check date slice of 4 into an int. Like so. Now it'll work. So here, that runs 2024-04-09 test size medium 10 add, boom, invalid previous year. Woo! Debugging pro. Let's go. All right, so now you can't add in, right? We took a slice off of this date and compared it to a slice of our current date from the datetime.date.today. And if it's less than, you're not going to get it. It's a previous year. So you can't add in items from the previous year. So then in the generate balance sheet, okay, cool. So in the generate balance sheet, what we'll do is we will say, okay, get the current year, right? We'll get the current year. If that year is within our previously existing year, that is the same, right? We're in the same year as when we launched before, then we're going to update and continually refresh that current balance sheet. Now, if we open the program and we happen to be in a new calendar year, well, we're going to, at that point in time, close off the 2025 and run on 2026, right? So that's what we'll do. So that's what we'll work on tomorrow. So what we did today is we successfully disallowed for previous years to be inputted for the dates via add item expense and transactions, and then also futures as well. So you have to transact within the current calendar year, which isn't super ideal, but it's honestly, I'm having difficulty thinking about how we could, like if you make a transaction if you go in for the previous year, you would have to go edit that balance sheet, but you would need to know, well, you could just fetch the current value of it that was sealed and then adjust from there. But I mean, that would work too. So what we could do is we could allow for dates in the past, and then if it detects that the date was in the past for a transaction or an addition of inventory, I mean, it's a slippery slope though, because what if they just made a mistake and they put in 2024? Well, then you're populating income statement for 2024 for cost of goods sold, So I think we should just keep it to you have to be within your current calendar year to add an item. And then the same thing will take place for transacting an item, right? And then if we go on the balance sheet, so what we'll do is, like what I said, is when you load the program, it'll read within the balance sheet page, it'll read the current year. If that year, right, to populate this matrix. Okay, yeah, that sounds good. Quit that. Okay, let's get add here. Added of past and future year. Okay. Let's push that. Okay. Cool. All right. All right, you guys, this is going to be it for me today. Thank you so much for being here. We're almost to 1650, so if two of you are out there that aren't subbed and want to throw a sub on it, throw a sub on it. I appreciate you guys for joining me here. Thank you guys so much for being here. My name is Michael. I stream every single day around 7 p.m. PST, where I teach myself computer science, specifically that of Python and various other topics. We're going to be diving into math-related topics like calculus and linear algebra soon. We're learning Git right now, reading Git. We're reading Fluent Python. We're also reading data structures and algorithms in Python. So a lot of content going on the channel. I have been teaching myself for about 10 months. I have a degree in human biology and a minor in chemistry. And I work as a formulation chemist for a biotech company, and I've been doing the streams every day for the past, 6 or so months after my 9 to 5 job. But I've been teaching myself for about 10 months now through various resources like these books, CS50, and just raw self-learning. So thank you guys so much for joining me. I'll be back tomorrow. Please consider leaving a thumbs up if you're still here, and consider subscribing. I really, really, like hanging out with you guys, and it really, really helps just to keep me motivated and also keep YouTube pushing our content out there. So I'll be back tomorrow where we'll get into Git branching in Chapter 3. We'll read Chapter 3 in its entirety, just like we read Chapter 2 today and Chapter 1 yesterday. I am going to be continuing to update the Git. I'm going to update the Discord that's down below for the Git section. I'm going to create a Git forum, and then in there post a link to the book, and then also to any videos and things like that that might be useful. So rather than just having a Git book link, it'll be a forum with all the Git resources in there that we find. So hey, we got 1649. Woo! We're one away. 1650. Ooh. Thank you, 1649, whoever that was. Really appreciate you joining me here and hanging out. Anyways, I'll be back tomorrow where we'll go into Chapter 3. We'll get working on a project, and then we'll also do some leak code tomorrow too. How about? So join me tomorrow for some more leak code practice. I think we're going to solve number 145 tomorrow. We solved 144, so 145 should be really easy, which is just another binary tree post-order traversal problem. So it should be really easy and straightforward. We might do a couple of them. I know you guys like the leak code. But anyways, I'll see you guys tomorrow. Peace out, guys. Have a good day.